Hi everyone. Today we're going to learn how to solve a system of equations using what's called Gaussian elimination. Gaussian elimination is going to allow us to ignore some of the variables in our computation for a little while and just focus on numbers and coefficients. Kind of like when we did long division with polynomials, we did synthetic division to ignore the variables and added them back in later. Gaussian elimination will do something similar for systems of equations. Gaussian elimination stems around using matrices, specifically augmented matrices. An augmented matrix is basically just the matrix of the coefficients and the constants of a system of equations. So I'm going to take out the variables and rewrite this as a matrix of just the coefficients and the constant. Each row should represent an equation. So this would be equation 1, this would be equation 2. And each column would represent the variable or the constant. So our first variable would be x, second variable would be y, and our last column would be our constant here. So just listing the coefficients, I have 5, -4, and my constant is -1. Then I have -2, 3, and 6. And this would be my augmented matrix. So once we have our matrix, I'm just going to erase my labels for a second. Our goal, and I should actually write goal down because we don't have this yet, but what we want to have is a matrix with all zeros and ones in the equation piece of our matrix. Now typically I'm going to draw a line here in my matrix to differentiate what the equation is from what the output is or the constant is. Okay, so equation side, constant side. And our goal is to get a matrix that looks something like this. So down our diagonal column here we have ones, and every other piece is going to be 0, or that's the goal. And then we have some constants here. Now let's think about why we might want this. Okay, in order to make our augmented matrix, I took the variables out. At the end, you're going to have to put them back in. So remember, this was my x column, this was my y column, this was equation 1, and this was equation 2. If I put my x's and y's back into this simplified version of the matrix, we would have x plus 0y is equal to some constant, which really would just give us x equals a number. In our second equation, we'd have 0x plus y equals some constant, which would give us y equals some constant. Therefore, if we get a matrix that looks like this, we've reached our goal. We have x alone, we have y alone, and we've solved the equation. Okay, so keep this in mind as we're working with our augmented matrix on the left here. Now there are 3 rules for Gaussian elimination, and they kind of relate back to regular systems of equations elimination. Okay, at any time you can switch any 2 rows if it's helpful. So I could switch these 2 rows if I wanted to. You can also multiply any row by a non-zero constant. So remember, in elimination, you could always multiply by like 2 if it was suitable and it canceled things out. You can do that in elimination here as well. And you may add a multiple of one row to another row. So I could multiply this by 2 and then add it to equation 1 here. Same rules as regular elimination, more or less. Now, although the rules are similar to regular elimination, our process is going to be just a little bit different. Okay, again, our goal is to get a matrix that looks like ones down this diagonal and zeros everywhere else. So you need to ask yourself, how can I get ones in this row and zeros out here? And I always start, by doing one of those things at a time. So maybe we'll start by just trying to make this 5 into a 1. In order to do that, I'm going to have to combine equation 1 or row 1 with row 2. So I'm going to label this whole row, row 1, and we'll call this row 2, R1 and R2. So if I want to combine with row 2, if I add them as they are, I'm going to get 3. So what I'm going to have to do is multiply R2 by 2. So what I'm going to do is I'm going to take 2R2 and add R1, and that's going to replace my R1. You'll typically see me use this notation here with R and R1, R2, and I'm going to show you what I'm doing and show you where I'm putting the new row. So let me explain this with the example. 2R2 would be, let's see, -4, and 3 times 2 is 6, and 12. Now I'm writing this up here because typically we don't write our steps when we're doing this. We just write what the new matrix would be. So if I do this step here, and I add our row 1 with 2R2, well, 5 and negative 4 is 1, negative 4 and 6 is 2, and 12 and negative 1 is 11. Okay, so all you're doing is taking 2R2 plus R1 and replacing that with the old R1. Okay, so this went into the old R1. Everything else I'm going to leave the same because I haven't combined row 2 with anything. So now we have a 1 in our first position, which is what we needed. In order to reach our goal, we're going to need a 1 in this position and zeros in this position. You can do it in any order you like, but again, I recommend you try and find an easy thing to do. For example, I have a negative 2 here. What would you need to add to negative 2 to make this a 0? Okay. Obviously, you would need to add 2, and this is really easy to do if we just multiply our row 1 by 2. So if we take 2 times row 1 and add it to row 2 and put that in the position of row 2, we'll get a 0 here. Okay, so 2 times R1, this would give us the row 2, 4, and 22. Now if we add that to R2, we're going to get a new matrix, and that matrix is going to look like, well, row 1 is staying the same because we're not changing row 1 at this time, but row 2 is going to be 0, 4 and 3 is 7, 22 and 6 is 28. So now we have a 1, a 0, and we just need to change this row to have a 0 and a 1, and you can do this in any order you choose. Keep in mind, we've added a bunch of rows together at this point, but we can also multiply a row by a non-zero constant. The reason I bring this up is because I noticed in order to make the 7 a 1, all I would have to do is divide by 7, which is the same thing as multiplying by 1/7. So in order to move to our next step, I'm going to multiply 1/7 by R2 and just change that row here. So our new matrix would become 1, 2, 11, and this 0 divided by 1 or divided by 7 is 0, 7 times 1/7 is 1, and 28 times 1/7 would be 4. So we've gotten so close to our goal matrix, only this pesky 2 is bothering us at the moment. Okay, so we're going to need to change row 1 one more time to get rid of this 2. Now the key is, keep in mind when you're changing this to get rid of the 2, you want to keep this a 1. And luckily, since we have a 0 beneath it, if we add the rows together, it's still going to say 1. So just keep that in mind in the future, though. So we need to get rid of this 2, which means we need to add it with negative 2. So what we can do for our last step is take negative 2 times our row 2 and add that to row 1 and then put that in the place of row 1. Okay, if we do that, we're going to take negative 2 times row 2, so that'll give us 0, negative 2, and let's see, negative 8. So if we add that with row 1 and put it in row 1 spot, we're going to still have, or not 0 here, we're going to have 1 here, we're going to have 0 here, and 11 minus 8 is going to give us 3. And our row 2 then is going to stay the same because we were just adjusting row 1. So now we have our goal matrix, and hopefully that means we can solve the system. So keep in mind we took out the variables for a second, or a couple seconds, a couple minutes, but we're going to need to put them back in at the end to actually answer our question. So remember, this was our x column, this was our y column, this was our constants. So that means our equations are x plus 0y equals 3, and 0x plus y is equal to 4. And we've solved our system of equations using Gaussian elimination. If you don't believe me that this works, you can always plug these back in and check. Now, I'm pretty confident in my answers, but of course you should always just check yours. I'm going to throw up another problem if you're interested in trying by solving through Gaussian elimination. So if you want to write this down and try it, I can go over the answers in AM support or in class. If you're up for a little bit more of a challenge, here is a 3-variable system that you may try as well. So these are optional. There's more in your homework for practice. I hope you had a good time with your Gaussian elimination and come to class with questions.